Hello everyone. Welcome to Learn at 7:30 p.m. with your friend. Let us begin the practice for term 2 finals. The topics for term 2 are quadratic equations, arithmetic progressions, some applications of trigonometry, circles, constructions, surface areas and volumes, and statistics. Okay, let us begin with the first one, that is quadratic equations. So, this is a fourth chapter, quadratic equations, and in this chapter, the objectives are standard form of a quadratic equation, solutions of quadratic equation, only real roots, by factorization by quadratic formula. The next point is relationship between discriminant and nature of roots. And finally, situational problems based on quadratic equations related to day-to-day activities. So let us discuss what are these points. Standard form of a quadratic equation. You have already learned what is a quadratic polynomial and what is the standard form of a quadratic polynomial. And even you have studied linear equations and standard form of a linear equations and so on. So for every equation or for an expression, there will be a standard form. That is the first thing. Second one, solution of quadratic equation. So what do you mean by solutions of an equation or solution of an equation? So you know that we are discussing here algebraic equations. So an algebraic equation is an equation which contains both constants and variables. So for an equation, in an equation there will be variables. So what do you mean by solution? Solution is the value of the variable for which the given equation satisfies. So we have to find out the value of a variable such that when you substitute the value, then LHS must be equal to RHS of that equation. So we have to find out solutions of quadratic equation. Different method, by factorization method and by quadratic formula. Okay. Third point is relationship between discriminant and nature of roots. The term discriminant may be quite new for you. So we will discuss about this particular term and what are the nature of roots and what are the difference or what are the relationships between these two. And finally, situational problems based on quadratic equations related to day-to-day activities. So you are familiar with situational problems even in your uh, equations, I mean linear equations, you have practiced so many questions. So here also there will be situational problems based on quadratic equations also. All right. Now before moving to all these points, so we have to think, why do we need quadratic equations or why do we want to study quadratic equations? Let us discuss a situation. Okay. For instance, so this is a hall. For example, suppose we want to build a hall in our school for our kindergarten children for their indoor activities or something like that. Okay, and but there is a particular condition for this one, that is this carpet area or the floor area must be some 300 meters square, something we can take. So it must be some 300 meters square. That's what they are saying. Okay, so they are saying that this must be some 300 meters square. Inside there must be the carpeted area. Okay, and there is one condition that whatever be the width of the hall, there is a relation between the width and the length. Okay, there is a relation between the length and the width of the hall. You know what is the relation? They have told its length 1 meter more than its length 1 meter more than twice its breadth. Okay, so if you take the breadth as some x meters, okay, the length must be one more than twice its breadth. So what do you mean twice its breadth? So if x is the breadth, two times breadth, and one more than the breadth. So look at here. So what is the condition? The length of the hall must be one more than twice its breadth. So if you take or if we take x as the width or breadth, the length must be one more than twice of its breadth or width. So this is the condition. So how can you connect this as a quadratic equation? You know that carpet area means the inside or the area inside that hall. Okay, isn't it? The floor area you can see. So how will you find out the area of a rectangle? This is in the form of a rectangle. You know that area is equal to length into breadth. So you know that area is equal to length into breadth. So instead of length we can go for 2x plus 1 into, and what about breadth? Breadth is equal to x. X is equal to length into breadth is equal to area, and it is given as 300 meter square. You know how to open the bracket. It is nothing other than distributive law. So 2x into x, we have to multiply like this. So 2x into x is 2x square plus 1 into x is x is equal to 300. So 2x square plus x minus 300 is equal to 0. So this is nothing other than a quadratic equation. Okay, so we will meet, or we have to discuss, or we want to discuss many situations like this, so that where we will use our quadratic equation. So we have to find out a value for x such that it should satisfy this equation. So once we got the value, we can substitute that value here and we can easily find out the length and breadth. So this is the condition that the person has told you. You have to build a room or hall like this under this condition. Okay. So this is a situation where we are using quadratic equation. Okay. Now let us see what is the standard form of a quadratic equation. In chapter 2, you have already studied polynomials, and one of the type was a quadratic polynomial. So it was in the form ax square plus bx plus c. Okay, so the standard form of a quadratic polynomial is ax square plus bx plus c, where a not equal to 0. So why should we write this condition a not equal to 0? This is a very important, because if a is equal to 0, what will happen? This entire term will get cancelled. Then the quadratic polynomial will reduce to a linear polynomial. So this condition is very important. So the general form or the standard form of a quadratic polynomial was ax square plus bx plus c. Okay. Now a quadratic equation is none other than, if you equate this is equal to 0, you will get a equation. See, ax square plus bx plus c is equal to 0, where a not equal to 0. And what about a, b, c? A, b and c are real numbers. Okay, so these are real numbers. So what do you mean by a quadratic equation? An equation of the form ax square plus bx plus c is equal to 0, where a not equal to 0. Again, if a is equal to 0, what will happen? This term will not exist. Then again it will reduce to a linear equation. Okay, so a should not be equal to 0, and a, b, c are real numbers. When you're writing not equal to 0, you have to put equal to sign here, and you have to cut from here to here. A not equal to 0. Remember. So this is a common mistake. Some of you will cut like this. This is not wrong. Okay, so once again, An equation of the form ax square plus bx plus c is equal to 0, ax square plus bx plus c is equal to 0, where a not equal to 0 and a, b, c are real numbers is called a quadratic equation. So this condition is very, very important. Okay, let us write an example. See, 3x square minus 6x plus 7 is equal to 0. This is an example. Here it is a is equal to 3. And what about b? B is equal to minus 6 and c is equal to plus 7. So when you are saying the constants or the real numbers with the sign you have to see. Okay, do not say just 6. It is negative 6. So always you have to say the coefficients. What is a? The coefficient of x square. What is b? Coefficient of x. And what is c? The constant term. In this question, the coefficient of x is negative 6. Clear? So let us take another example. 7y square minus 14y plus 32 is equal to 0. So can we say A, B, C here? Here A is equal to 7, B is equal to, you must say negative 14 and C is equal to 32. So whenever you are saying the real numbers with the sign you have to say. Okay, with sign you must say. So the coefficient of y is negative 14. So this is a quadratic equation in y. So you can write quadratic equation x, y, m, n, anything. Okay, so here y is the variable. In the previous question it was x was the variable. So how can you define a quadratic equation in a variable x? A quadratic equation in a variable x is of the form ax square plus bx plus c is equal to 0. A quadratic equation in y is of the form ay square plus by plus c is equal to 0. Remember, whatever be the variable you are using here, it must be throughout the equation. Clear? So this is the general form of a, or the standard form of a quadratic equation. So hence we can conclude that the standard form, we can conclude like this: standard form of a quadratic equation is ax square plus bx plus c is equal to 0, where a not equal to 0 and a, b, c are real numbers. Okay, so this is a definition of the standard form of a quadratic equation in x. Clear?